Welcome back. We're now going to embark upon grade 12. I'm going to start with physics, and once again, I'm going to be doing it in the order of most textbooks. Yours might be, or your teacher might be doing it slightly differently. Let me just set my timer going there so that I can check on the time. Otherwise, I tend to just keep talk. So let's just recap some of the stuff that we've done. The first chapter in each physics was the classifications and some graphs, some definitions and things like that. It's very often skipped, and there will be questions on it, usually involving a graph and some data that you're going to be given. Let's just have a look at some of that stuff, shall we? So over here, I'm just going to have a look. Okay, first of all, if you remember, we've got the independent variable. Okay, we've got the independent variable and the dependent variable. All right, the independent variable is what we put on the x-axis, is independent. And obviously the next one on the y-axis is going to be our dependent. Okay, so what are we actually doing? Well, the independent variable, this is the one we change during the experiment, all right? In other words, we move x and measure y. Basically, that's what we're doing, isn't it? We are moving the x, all right? Say, for example, we're changing current or voltage or whatever the case might be and measuring whatever, all right? Could be temperature even. So as we move, we measure what is happening. Usually, or most often, this one happens to be time. Time we plot on there. That's the one that's moving along. Sadly, we can't stop it. We can't change it. Sometimes I wish one could, but we have to plot that along that axis that's moving, and then what do? We measure what happens. The temperature change, for example, of a substance that's put on a gas flame, how quickly it takes to boil, let's say, for example. If any of you have got access to or a magnetic induction hob, brilliant, you know, go and have a play with that and do some timing. But those are the two things, and they're going to ask in various sections of this, when there's some experiments, they're going to ask, name the independent, name the dependent variable, etc., etc., okay? Right. Now, so that's the first little bit of this section, okay? Now, you're going to be asked on things. Let me just get this guy up a bit over here. There we go. Just move it out the way. Then we're going to be looking at this proportionality. Okay? Proportionality. What am I talking about? Essentially, we're looking at data, x and y, okay? And we're looking at how the data, how is x and y related, okay? What's the relationship between them, right? Now, essentially, you know that on a straight line graph of x versus y, you know that you get y is equal to mx plus c, correct? Essentially, that is a straight line. Right? Now, in the physics, we're going to say if y is proportional to x, this is going to be direct proportion. Let me put this as section 1. Direct proportion, okay? I'll leave out proportion if you don't mind. Direct, it means y is directly proportional to x. What does that mean? Well, essentially, you remove, in order to change a proportion sign like that to an equal sign, you insert the constant of proportionality k. Let's call that the constant of proportionality. Okay? Constant of proportionality, right? We do it that way. Now, let's just do this. K is thus equal to y divided by x. Right? Now, if they give us a bunch of data, we're going to go through another couple of these. But they're going to give us data, and I've just got it here. I've called it a results table. Okay? result table like so, and they give us data x and data y. Data point, data point, data point, data points like that, okay? What they're doing is they're giving us a whole bunch of data points, all right? My graph is now sort of off your screen, but they're giving us those. What do? We need to test, because the question they ask is, what is the relationship? Okay? And we're going to see direct proportion, indirect proportion, right? We're going to see proportional to a square, inversely proportional to a square. Don't worry about it at this point in time. What do? We first of all, we list the data like that, okay? Then this is a list. Then we say, okay, let's put in here, take y divided by x, and we get a whole string of numbers, okay? We do this for each one, for the different tests. This is our first test. If this over here comes out to be constant, then that is k, the constant of proportionality. So what I've done is I've divided it, so we have found k. You with me? So what are we saying? We are saying, therefore, x is directly, or y, directly proportional to, I'm actually going to change it around. I'm going to say, y is directly proportional to x. Y is directly proportional to x. Okay? So what do? I get given a whole bunch of data, and the question they're going to ask me is, essentially, what does the graph look like? They're saying, what does it look like? Is it a straight line? Is it a curved line? Is it going up, down? Which way is it going? And first of all, we say, right, let's take y and divide it by x, because remember, that's what we did to get k. Now let's have a look at the next one and say, all right, they give us more data now. I'm just going to turn over my page, just so I keep it in the same order. Then they say the direct square. The direct square relationship. Okay? This one we say then y is proportional to x squared. Therefore y is equal to constant of proportionality, kx squared. Therefore k is equal to y divided by x squared. Yep, no prizes on this one for guessing. What do? So they give us data. They give us x, okay? We then square x, we write down y, and we calculate y divided by x squared, and we get a whole load of numbers for each data point. Let's say this is 3, and this then becomes 3 squared, which is 9, and let's say y was 12. This then becomes 12 divided by 9, okay? Then if the next set of results, okay, for example, let's just do one. 6, 36. So therefore, y over there is 12 divided by 9. 12, okay, 12 divided by 9 is equal to 4 over 3. 4 over 3. If I get that this is also equal to 4 over 3, it's the same, okay, which means that it is k that we've worked out, which means that it is directly proportional to the square. All right? You can see the method is the same for each one. Put the table down. First of all, take y over x. If that's constant, it's a straight line directly proportional. If that doesn't work, what do we do next? Next one is we say, right, take x squared and then divide y by x squared and see if that is the same. If it's the same, then it means it's proportional. Isn't that so? So basically 4 over 3. So you can say, well, in this case, we can do a quick calc and see what it's going to be. It's going to be y over x. So y over 36 must be equal to 4 over 3. Therefore, y is going to be equal to 36 times 4 divided by 3. 6 times 4 divided by 3 is going to be equal to 48. Okay? Because 48 over 36 divided by 36 is equal to 4 over 3. Okay? So, yeah, that's pretty straightforward, pretty simple, isn't it? Next, the next one in the series, and it's the same. I've got to do a new page. The next one in this series, that we're going to do an inverse proportionality. Okay, and as usual, I have to get my pen. Inverse proportionality. Inverse proportionality. What do I do here? Well, inverse means it's summing over, okay? So I say, okay, then I say y must be equal to, or what, sorry, let me just go back. Y is proportional. I can't use an eraser. Y is proportional to 1 over x. Once again, I change that to be y is equal to k times 1 over x, which is the same as k over x. Please note that if I drew a graph of k over x, it's a hyperbola, isn't it? So therefore now I say x times y equals k. So I'm given a whole set of values x and y. I check x times y. And if 2 times 3, 6, and I've got 6 times 1 over there is 6, okay, those are equal. That proves that that is equal to k, in fact. So k is equal to 6 for that one. They are the same, therefore they are inversely proportional to each other. Simple as that. That's all you're going to have to do. Right, so what is the last one? The last one is inversely proportional to the square. Okay, I'd love to give out prizes, but I'm sure if you guess, you can say inverse square. Oops. Inverse square. Okay, y is proportional to 1 over x squared. Therefore, y is equal to k over x squared. Therefore, k must be equal to x squared times y, correct? X squared times y. The graph, by the way, for that looks like this as well. All right. This is y is equal to k over x squared. Okay. So therefore, what do you think I do? Yes, I write down the values. I write x, I do x squared, I do y, and the last thing is I check to see if x squared times y is a constant value. Though the recipe is the same, isn't it? I write down x, I write down y. I check y over x, I check y over x squared, I check xy, and I check x squared times y. That's as simple as it is. Please, just before we leave this off, please note, I've made a little note to myself over here. Y is equal to 1 over x or 1 over x squared. Please note that what it does do is it changes the graph from one of those to a straight line. We will see that when we get to gases. Okay? There's a specific one. Watch what is put down here on this axis. All right? Please note that that's where a potential trick comes in. Usually in the gases, they get a multiple choice. It represents whose law, Charles's, Boyle's, whichever law, and which is the best representation of it. They will, in all likelihood, put in a 1 over x or a 1 over x. Well, in the gases, 1 over x squared for something else. Then it changes it to a straight line. Okay? Please don't neglect these little bits and pieces when you're doing these experimental sections. Okay? Don't neglect them, guys. It's very, very important. Why? Because in this little section here is a couple of percent. And it's not difficult work. It's not a great deal of understanding. It's very, very bang, 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 bang. Okay? And yeah, you know what? If there's 3 or 4%, well, then that's cool, isn't it? Then it's great. Right. Now, before we move on and start the syllabus officially, all right, well, I guess this is part of it. We're going to work through it, as I said before, according to the way the textbooks work through it. Now, how are you going to get the best out of this? As I've said, for those of you who've done it with me before, please make sure you've got your textbook, but you've got notepads, okay? Stop the videos and make a note. Go back. Make sure as we go forward, each bit and piece, because obviously I can't physically examine every aspect, and there's going to be questions. what we're going to do is we're going to add more and more content as we go on. As students ask for more, we're going to add more clarity on points, etc., where it's not absolutely 100% that somebody can get it first time. Just go back, go over it again, and go with me through the process, okay? Make a note of some of the recipes that we use, like that one that I just did now. Make a couple of notes of those. Keep a separate file for say, Kevin's classroom, and use it when you're doing the work. A lot of the examples we're going to do are examples which are pretty much straight out of the books you're using, okay? There's only so many ways that anybody, even at uni, they can only ask it in a certain amount of ways, right? We can't ask you things that I know this sounds really stupid, but they can't ask you things that you haven't done or that you haven't got the maths to solve, right? So what are we looking for? We're looking for straightforward identification of type of problem. Usually, the identification or the problem ID is they ask you usually for the law up front. State Newton's law of this. State Newton's law of gravitation, or state Coulomb's law, right? Then usually the questions thereafter are related to that. Okay, law of conservation of energy, right? Then they're going to ask you problems on it. And the next section we're going to do is momentum, and then it's linked to the energy equations thereafter. Right, I'll see you in the next one. This one is a little bit shorter than normal, but I'll see you in the next one, and then we'll get going with momentum. Cheers, and you know what? As I've said, you've got the physics, you've got the chemistry, you've got the maths on the site, and whatever else over the years that we add to it. But yeah, let's work it together. You know, that's what this is all about. It's entirely up to you. I'd love to be able to do and have a direct interaction with every one of you. Unfortunately, I can't. It ain't possible. But yeah, let's go for it. Cheers. I'll see you in the next video, and let's go do some momentum. Bye.